Chapter 4 Materials, Metals and Non-Metals. Hello students, welcome to today's topic Metals and Non-Metals. Take a look at things around you. Your school building, house you live in, cooking utensils in the kitchen, machineries in the factories, bridges, electric and electronic items of home appliances. All these items are made up of hard and shiny materials. These materials are strong and durable. On the other hand, you must have seen jewelry which are made up of gold, silver and platinum. These lustrous materials are less reactive towards air and water. These metals find a unique place in Indian culture, are expensive and play a prominent role in the Indian economy. You may be knowing that gold, silver and platinum as precious metals. Now tell me, what are metals? And how do you identify metals from non-metals? What do you think about diamond? Like gold, silver and platinum, diamond also shines and is very hard. Then, can we call it as a metal? No, diamond is a non-metal. Then what is our conclusion? All that glitters are not metals? If this is the fact, then what are non-metals? How non-metals are different from metals? What are their applications in our day-to-day life? These questions must be intriguing you, and I am sure you are now more curious to know several facts about metals and non-metals. Come, let us explore more about metals and non-metals in this lesson. In your previous class, you have studied about matter and their classification. Based on their chemical nature, it can be assorted into pure substances and mixture. Pure substances are further categorized into elements and compounds. An element is a substance or a material that is made entirely from one type of atom. Elements can be viewed as metals, non-metals and metalloids. All of them possess their characteristic properties. Metalloids, probably a new term to hear. These metalloids own properties of both metals and non-metals. Typical examples are silicon and germanium. They are used mainly as semiconductors, a component in transistors. In the present lesson, our focus of learning is metals and non-metals. Of 118 elements known today, 95 are metals, 22 are non-metals and rest are metalloids. Generally, metals represent themselves as solids. Non-metals are capable of existing in all the three states of matter. Hence, 10 are solids, 1 is liquid and remaining 11 are gases. With this background information, let us proceed further to discuss the physical properties of metals and non-metals from our teacher.
Welcome children. Today we are going to learn a new chapter called Metals and Non-Metals. What are the properties, what are the reactions, what are the uses which vary from metals and non-metals, how they differ from each other? That is what the whole chapter is all about. Yes, you have to categorize the substances depending upon their dullness and their softness. You have to categorize substance into hardness and shininess. Okay, categorize. Yes, they have categorized into two different groups. These groups, as they have identified the substances into the nature of shyness and the hardness of the substances. Here they have identified based on the softness and dullness. So what we can conclude from this categorization is nothing but the substance which are shiny as well as hard are going to be classified as metals, and the substance which are going to be soft and dull are going to be categorized as non-metals.
Alright, based on the lustrous and hardness, we can distinguish metals from non-metals. Iron appears shiny and very hard. Coal appears dull and not very hard. Sulfur appears dull and soft. Aluminium shiny and hard. Copper is shiny and very hard. Metals are bright, lustrous, hard, except for sodium and potassium, which are soft and can cut with a knife. Generally, metals are solid at room temperature. One exception is mercury, a liquid at room temperature. Non-metals are dull, non-lustrous, either not very hard or soft or brittle except for diamond. In contrast, the diamond is very hard and shiny. In fact, it is made up of carbon atoms similar to that of graphite and charcoal. All these constitute different allotropes of carbon, that is, diverse structural forms of the element carbon. Diamond is lustrous and hard due to its crystalline nature and three-dimensional structural arrangement of carbon atoms. Among non-metals, carbon, sulfur, phosphorus, iodine are solids and only bromine exists as liquid at room temperature. Oxygen, nitrogen, hydrogen represents gases. Observe what happens to these materials when hammered.
Now students, let us perform the second activity. In this activity, you have to identify some materials are given to you, and you have to identify which will become flat and which will remain as such or which will break even. So these are the kind of classification you should make in these materials. Okay. Now if I hit this iron nail you have seen in your home, what will happen to this? See what has happened to this?
It has flattened.
Yeah, it has become flat. Okay. So based upon this observation, you have to classify this materials which is given here, and the flattening property of this material is known as malleability. Okay. So this is an exclusive property of a metal, and non-metals such as coal will not become flat, rather what it will become?
Powder.
See, it has become powder. Okay. So I'll keep here, you classify into two and tell me which materials are malleable and which materials are non-malleable. Yes, carry on.
Iron nail flattens, coal piece breaks into pieces, aluminium wire flattens, copper flattens, pencil lead break into pieces. The property of metals by which they can be beaten into thin sheets is called malleability. Malleability is a characteristic property of the metals. Coal and pencil do not show this property. Hence, they exemplify non-metals. In the kitchen, while cooking, will you able to hold a metal pan or pot? No, because while cooking, metal pan or pot is hot. So, you use a cloth or a holder to grab that hot metal pot. You might have also noticed that some utensils will have plastic or wooden handles to prevent us from getting hurt. While heating, metals absorb heat and become hot. In contrast, wood and plastics are poor conductors. Let us perform an activity and find out how heat flows through a metal rod. Select an aluminium rod. Fix wax pieces with little distance apart and start heating at one end of the aluminium rod. Carefully observe the changes. Though only one portion of the rod is heated, wax adhered at different location of the aluminium rod melts and drops one by one. The wax very close to the heat source melt partially and detaches first, and that at the other end melts later. This observation reveals that heats flow from one end to another through the metal. From this experiment, we can conclude that metals are good conductors of heat. Let us do one more experiment and find whether electricity can pass through an object or not. Connect a battery and a bulb through an electric circuit and try to glow the bulb. Now, disconnect one end of the wire and complete the circuit through different objects and observe which one allow electricity to pass through and will enable the bulb to glow. Iron nail allow the bulb to glow. Magnesium ribbon allow the bulb to glow. Sulfur stick will not allow the bulb to glow. Coal piece will not allow the bulb to glow. Copper wire allow the bulb to glow. From this experiment, we observe that metals conduct electricity. In comparison, non-metals do not conduct electricity. Exception for this is graphite. Being a non-metal, conduct electricity due to its unique structural arrangement of carbon atoms. After watching these experiments, now we can make a statement that metals are good conductor of heat and electricity.
Students, I have some materials with me. First, what is this?
Metal wire.
Yes, metal wire. Can you tell me what is this?
Wire which is coated with plastic.
Okay, good. Wire coated with plastic which is used in electrical appliances. Can you see this? What is this?
Copper wire.
Copper wire. Okay. This one?
Coal.
Coal piece. This one?
Sulfur.
Sulfur. So, if you see, these are into wire form. Okay, you have told it is a copper wire which is made up of copper metal, and this is an aluminum wire which is made up of aluminum metal. Even inside this there is a copper wire. So, but we cannot see this sulfur wire and the coal wire. It cannot be drawn into wires. Okay, this special property of making the metal into wire form, okay, making into thin wire form is known as ductility. This special property of metal is known as ductility. Can you tell me where all you have seen such wires?
Electronic appliances.
Yes, very good. Electronic appliances.
Telephone wire.
Telephone wires.
Musical instruments.
Musical instruments.
Iron fencing.
iron fencing. So these are the applications of this property of metal, and this property is called as
Ductility.
ductility. Have you understood this one? Yes, very good.
The property of metal by which it can be drawn into a wire is called ductility. Do you know 1 gram of gold can be drawn into approximately 3 kilometer long wires? Look at the table which shows the melting points and boiling points of metals and non-metals. Metals generally have a high melting point when compared with that of non-metals. An exception to this is sodium and potassium. They are soft metals with low melting points. Similarly, diamond being a non-metal, which is an allotrope of carbon, possesses highest melting point. Tungsten metal is used as a filament in electric bulb because tungsten can sustain high temperature, high melting point and high resistivity. Fuse wire need lower melting point. Hence, fuse wires are usually made up of alloys of tin and lead. We hear a unique sound while washing utensils or clinking piggy bank containing coins, or when a metal plate or coin is falling on the ground. Whereas coal will not produce any sound on falling. What is this physical property called?
Students, here is an activity which is very familiar to you, which is just making sounds using these substances. Now, this group has to make sound using these instruments, and you have to make sound using this one. Will you do?
Yes, sir.
First this group, you do sound using these two. More. Okay, enough. Now you try making sound using this. Yes. In which among these two you find a ringing sound? In this or this? Yes, in this we get a ringing sound. Why we get a ringing sound in this and not in this?
Because the metal touches.
Yes, it is made up of metal, and metals give ringing sound, and this property is called as, any guesses? Yes, this property is called as sonorous. Okay, and this is made up of silver metal. Where all you have observed such ringing sounds?
Railway station.
Railway station?
In school.
In school?
Temple and church.
Temple and church?
Cycle bell.
Cycle bells? Yes, you have seen in different places. And this special property of metal makes it so special, and it is very useful for our daily lives.
The physical property of a metal to produce ringing sound when struck on a hard surface is known as sonority. Since metals produce ringing sound, they are said to be sonorous. Non-metals are not sonorous. We have learned a few important properties of metals and non-metals. Come, let us recall them once again. Metals are hard, lustrous, malleable, ductile, sonorous and good conductors of heat and electricity. Examples are copper, zinc, aluminium, gold, silver, etc. Non-metals are dull and soft in appearance. They break down into powdery mass when hammered. So they are not malleable. They cannot be drawn into thin wires. Hence, they are non-ductile. They are not sonorous and does not conduct heat and electricity. Examples are sulfur, carbon, nitrogen, oxygen, phosphorus, etc. Some applications of metals based on their physical properties are as follows. Metals are conductors of heat, so we use them in cooking utensils. Metal plates and containers are useful to eat food and store food items. Aluminium foil generally used to wrap food items. Metals such as platinum, gold and silver comes under the category of precious metals and have high economic value. These metals are widely used in making jewelry sets or to make some decorative items. They are used extensively in manufacturing machines for industries, agricultures or farming and automobiles, which include road vehicles, railways, aeroplanes, rockets, etc. You can observe here the commonly used metals are iron, aluminium and steel. Malleability also allows for repair of some metallic objects if they are deformed. Some other uses and applications of metals are they play an essential role in security as metals are useful in making locks, strong safe, doors, etc. Apart from this, furnitures are made from metal these days. Metals also find uses in military where they are used to manufacture weapons and ammunition. Metals are good conductors of electricity and are therefore useful in electrical conducting wires and appliances. Some metals are used in galvanizing to protect them from rusting. Here are some questions for you to ponder about. List out all the metal items in your kitchen which are made because of the high malleability of metals. Which is the most malleable metal? Note down the various usage of metal wires around us. Why do electrical wire have plastic coverage? Plastic insulate the conductor used in the electrical system. It prevents accidental contact with other conductors of electricity. Safety of the user is another reason for the plastic coverage of electrical wires. Similarly, nowadays LPG gas pipelines designed for laboratories are made up of copper pipes and are covered with a PVC coating for a better life and also protect it from the chemical reactions. What is a chemical reaction? How do metals and non-metals react with each other? We will learn this and more in our next part of this lesson. Thank you.